In this tutorial video, we will be learning on job sequencing with integer lengths. We will be doing the coding in Google Colab. Like we did in the previous video, we will be starting with installation of Blueqat. Type the code !pip install Blueqat in order to install Blueqat. Let us do it in Google Colab. Type the code that was shown earlier and click on the play button to run the code. Blueqat will be installed after a while. The sequencing of jobs on a single processor, with integer lengths is called as job sequencing with integer lengths. Here, we are given a set of jobs. Each job has been assigned to the machines. Only one processor is available for processing all the jobs. Processor takes 1 unit of time to complete a job, and the total size of jobs assigned to the machines will be given by assigned job sizes. Let us create a QUBO class in Google Colab. We have a set of n jobs to run on a processor, that is, CPU or machine. Let us import Blueqat.opt as wildcat, and also importing numpy as np. First, create a class QUBO, type the codes. This defines the function of initial point of n jobs, and n machines, with the self-Hamiltonian of A1, A2 and B individually. Then next, defining the function of calculation of sum of n jobs and n machines. Then, ranging the machines in n jobs plus 1, with QUBO matrix individually. Then next, defining the function of calculation of sum of n jobs only, where n jobs in range of 1, and the maximum delta plus, with the QUBO matrix individually. Then next, defining the function of calculation of I beta, in range with n machines and creating the QUBO matrix individually. Then next, C equals defining the function of calculation of sum of variable I and j, where j in range of n jobs and I plus 1, with QUBO matrix that we have created till now, with the length of the integers individually. Then next, defining the function for calculation of sum of I and n jobs with length of the integer, and ranging the n jobs in maximum delta plus 1. And calculating QUBO matrices with the length of the integers individually. Then next, defining the function of calculation of sum of I, in range of n jobs, and calculating the QUBO matrices with the length of the integers. Calculating the functions of sum of I and beta, I and j, and I and n jobs individually. Then next, defining the function of calculation of sum of constraint, for in range n machines, and calculating the QUBO matrices of I and n jobs individually. Then next, defining the function of calculation of objective, for I in range of n jobs, and calculating QUBO matrix with the length of integers. Then next, defining the function of calculation of QUBO matrices. In this, we will be calculating the constraint function and objective function individually with QUBO matrices. Then next, defining the function to get the QUBO function of matrices, where the QUBO is printed with numpy of zeros consisting of sizes of jobs, then calculating the QUBO function individually, and returning the QUBO. Finally, let us type the codes to show the answers. Firstly, we printing the solution, followed by showing the assigned job sizes with numpy of zeros, with the n machines, and the data type should be an integer type, with the range of I and n jobs individually, and assigned as false. Again, range the alpha and n machines individually. If the solution matrix is greater than 0, then print as the job has been assigned to the machine, and also assigned as true. If the assigned is equal to false, then print the job has not been assigned. Lastly, print as the total size of the jobs assigned to the machine is equal to assigned job sizes. Let's solve it. We choose Hamiltonian A1, A2, be looking at the total balance of each terms. Firstly, let us type the numbers of lengths of jobs, followed by assigning n underscore machine as 3, then assigning max delta as 7, but you can select by yourself. Then assigning A1 as 1, followed by assigning A2 and B with the maximum jobs. followed by creating the QUBO matrix with jobs, and machines, max delta and the Hamiltonian A1, A2 and B. Then, getting QUBO function. Then, printing the solution in range of 10. After running this code, we get ten answers with the solution as constraints, the jobs that has been assigned to the machines, and the total size of the jobs that have been assigned to the machines. Thank you for watching this video.